Hi, so these are the notes, the video notes for 4.3 rotations. I did finish these notes during class, but this is for your reference in case you missed class or need to go back and review some things, okay? So we said that rotations is a transformation where you turn a figure about a fixed point. We say it in our own words. Basically, you just turn the figure. Okay, our fixed point is called the center of rotation. On the graph, the origin will usually be our center of rotation. And then depending on how many degrees your object rotated, that is your angle of rotation. So on the graph, we usually rotate 90, 180, or 270 degrees. Also, you need to know that when you do a rotation, you will either go clockwise or counterclockwise. Clockwise is the same direction as the hands on the clock. So this is clockwise. Counterclockwise goes the opposite direction as the hands on the clock. So normally in class, if the problem says to perform a rotation and it doesn't tell you whether it's clockwise or counterclockwise, then you will just do counterclockwise. Okay, so always rotate counterclockwise unless the problem specifically says to go clockwise. We do not do 360 degrees. So a 360 degree rotation does not count as a rotation. And that's because 360 degrees simply means that the object turned around and back to its original position. And a counterclockwise is in the positive direction. So that's a positive rotation. The coordinate rules for rotation. So this is what your book says, but please feel free to rewrite it in your own words if this confuses you. So your book uses A, B instead of X, Y. You need to know that for a 90-degree rotation, the rule of the coordinate rule is negative BA or negative YX, which means flip the numbers around. In other words, put the Y first and the X last, but you're going to change the sign of the Y. So negative Y does not mean just make a negative, because if it was already negative, you would turn it into a positive. For 180-degree rotations, the rule is negative X, negative Y, which means change the signs of both the X and the Y. For a 270-degree rotation, the rule is Y negative X. That means put the Y first and the X last, but change the sign of the X. And I did give you an example of a rotation and how it looks. So this figure got rotated 270 degrees, okay? A 270-degree rotation. So watch when I turn the graph. Watch this green dot up here at the top, and I'm going to go in a counterclockwise direction. So when I turn it sideways, the x-axis went from here to here. That's 90 degrees, okay? Then I turn it again, the x-axis went from here to here. So that's another 90 degrees, which is 180 degrees. And then one more turn like this. So another 90 degrees plus 180 is 270. So 270-degree rotation is basically 3 turns to the left, okay? You can use the rule to find the coordinates, or you can use the graph. Remember, the blue figure is the pre-image. Oops. The blue figure was the pre-image. When I turned it 270, 90, 180, 270, look at the blue figure and look at the points. Okay, we're pretending this is a regular graph. Point R is to the right 1 and down 3, so those coordinates is 1, negative 3. But if you use your coordinate rule, you would have switched the Y with the X, but then make the X number the opposite sign. Same thing with points S, T, and U. Notice point T. If you use the coordinate rule, you take your X and Y and you flip them. So we put the Y coordinate first, you put the 5 last, but the 5 changed to a negative because it says negative X. All rotations are a rigid motion. What's a rigid motion? Remember, a rigid motion means that the object will remain the same size and the same shape. And another word for rigid motion is isometry. So we did do this one in class. We did a 90-degree rotation. 90 degrees rotation means turn it to the side. Watch the green dot. When I turn it, I'm going to turn it. See that? The y-axis went down to the x-axis. So the y-axis traveled 90 degrees. That's how I know I did a 90-degree turn. Now, if I look at my graph, look at point A. Point A is left 2 and up 1. So that's negative 2, 1. Point B is left 4, up 2. So that's negative 4, 2, etc. Or you can just use the coordinate rule. So remember the coordinate rule, you take your coordinates, you flip them, right? So point A right here, I'm using the coordinate rule. I'm going to put the 2 first and the 1 last. See how y comes first and x is last? But I'm going to change that 2 to a negative 2 because it says negative x. I'm sorry, it says negative y, which means change the sign of y. Did the same thing with the other coordinates. For 180 degrees, your rotation is 2 turns to the left. First I go 90 plus another 90 is 180 degrees. My graph slid a little bit, okay? Or you can consider 180 degrees as turning it upside down, right? Because if 360 degrees is a full rotation back to its original position, then 180 means it's halfway around, which means it just turned upside down. So you can use the graph to find your coordinates or use your coordinate rule, negative x, negative y. That means change the signs of both the x and the y. For 270 degrees rotation, that's 3 turns counterclockwise. I got 90, 180, 270. So this is a 270 degree rotation. Or use the coordinate rule, yx. So for each one, put the y first and the x last, but change the sign of the x number, which is what we did here. So this problem was on a Desmos activity that I gave you recently, and many of you missed it. So this little puzzle piece, we're going to do a 270 degree rotation. So let me trace these little, I don't know what to call them. I'm going to call them these little curly hump thingies. Oops. In fact, I'll just trace the whole thing. Yeah. Trying to trace it. Okay. So I traced it. 270, that means 3 turns. So let's say I start here. I'm going to put a star, meaning this is where I start. So if I turn it to here, that's 90. And then when I turn it to here, that's 180. And then when I turn it to here, that's going to be 270. So watch me do the turn. That's 90. That's 180. And that's 270. There. See my puzzle piece? Let me slide this out the way. Now, here's the puzzle piece. I just did a 270 degree rotation, which is B. So that's what B is. Okay? Rotational symmetry. We talked about symmetry when we did reflections, right? We said that when you reflect the figure over a line and it looks exactly the same on both sides of the line, and we have symmetry. And that's line symmetry. Well, rotational symmetry means you can turn an object and it still looks exactly the same. So check out this little pinwheel. I did trace the pinwheel because I'm going to turn it And we'll see when it looks the same. And I'm going to count the turns. I did this in class already. So I'm going in the counterclockwise position. I'm turning. So when I get to this position, and I slid a little bit. So far that's one turn where I have symmetry because it looks the same. I'll turn it again. In this position, it's the same. So that's two turns. And then now I'm in this position and it's the same, and that's three turns. And I'm sorry, it keeps sliding, so that's why I have to keep moving it back over. And then don't stop turning till you get back to your original spot, the 360 degrees. So at 360, that's my fourth turn. So to find how many degrees of rotational symmetry an object has, you take 360, which is a full circle, and always divide it by the number of turns that you were able to do. So 360 divided by 4 is 90. Therefore, this pinwheel has 90 degrees of rotational symmetry. Identifying rotational symmetry. Again, we did this in class. So for the parallelogram, I was able to turn it twice. So I'm turning. Once I got upside down, that counts as 1. And then I'm still turning. So now I'm back at my regular position. That was 2 turns. 360 divided by 2 is 180. The parallelogram has 180 degrees of rotational symmetry. For the regular octagon, so I turned it to this position, that counted as 1. Oops, let me move this out the way. So this is 1. This is 2. It's sliding a little. That's 3. That's 4. That's 5. 6. 7. And back to the top. That's 8. So 360 divided by 8 is 45. So the octagon has 45 degrees of rotational symmetry. Now for the this is a trapezoid. Let me get this out of the way. So for the trapezoid, I turned it. Nothing, not matching. Not until I turn it completely around to its original position do I see symmetry. That's only one turn out of a full rotation. 360 divided by 1 is 360, but remember, no figure has 360 degrees of rotational symmetry. Your symmetry has to be less than 360. So if you don't get anything less than 360, then we say the figure has no rotational symmetry. So for the trapezoid, it was none. Okay? And that was it. So be sure to turn in your notes on Google Classroom. You can fill in the slides, or if you wrote on paper, take pictures of it, insert it, and send it to me. Let me know if you have questions or need something cleared up. Take care.